Okay, so here we go. I've got the recording on. This is our lecture for Design 300. It's Tuesday, September 21st, and we are on Google Meet. So let's take a look and see. We're looking at, again, foundations and stem walls. So it's part of the concrete stuff that we've been doing. It's really a continuation of last week. Some of it overlaps. And we're focusing again on concrete foundations because that's used around here a lot. And stem walls are the foundations are the things that transfer the flooring, wall, roof loads to the ground. And so the foundations are generally considered the part that touches the ground directly, and those are usually spread out. And the stem walls stick up out of the ground to where you can attach the floor and everything where you want it. So that's what we're going over. We're going to talk about footings, stem walls, and rebar in particular. And not a lot about rebar, just a little bit. Things to attend, view, or read. We've got your 2 lectures for this week. Here's the link to them, and I'll put the recordings on as soon as I'm done. We do have a playlist. Not too extensive this week because you really hit a lot of it last week. But this is a really, really good video on concrete stem wall foundations, and it's very short. And this Revit Basics, how to add drawing details to Revit. So you're getting another, it's different than doing annotations, and there are some annotations on it, but it's just getting a little bit familiar with that program again. And just really what we're doing is we're using Revit to show you all the different types of drawings that you might see during a construction project. That's part of your material resources, is how do you read the drawings to find those out. So that's what we're looking at here. One more thing to do, and it's pretty straightforward. This is a very direct presentation of it, so you should be able to get through that. And of course the lectures will show up in here too. There's again a little bit of a reading list. So there's a document, as we've been using before. It's a Google slide presentation. There's 3 slides to it this time. And so this one talks about a footing. It's the part that's spread out in the ground and what it's for. And then there's a part about post and pier. So this is a type of footing. But you can see that this is a post and this is a pier, and you can see a little bit about how they go together and how they connect and maybe what's going on. And if you've never crawled around, I don't like crawling around under my house. There's dead things under there, and it's all musty and gross, so I don't crawl around under my house too much. But I have been under there, and there is a foundation around the outside, and then there's some post and pier. My house doesn't have big spans in very many places, so most of it, there's like 2 or 3 posts total. And then there's something called the stem wall, and I wanted to introduce this idea of CMU, concrete masonry unit. There's pour in place and CMU, and then you can see some rebar here, and we've seen it throughout. So you'll get a chance to kind of read that and look at that. This is a really cool thing. This UpCodes takes part of the California building code and puts it online for us. And so here's a section about footings, and it's just good. You don't have to memorize this or know anything off of it. I'm looking to you to do kind of what I'm doing. Oh, snow load, roof load, load bearing, veneer. What are these things? You should know that they exist and not much more about it. at this point. We get into that in other classes. What's PSF? Pounds per square foot. Pounds per square foot, not pounds per square inch. Here's some stuff. So they've got a lot of things in here, and we're going to actually use this this detail in our own drawings, and that's something that we have to do fairly often. So there's a little link to that that's kind of useful. There's another one for foundations, and then another one for, so there's 3 little spots here where you can go. The goal is that when you go into one of these, like if I'm talking about rebar, let me just go there and I'll do Control F. Rebar doesn't have anything, but reinforcing bar does. Reinforcing. And then you can go through there and just reinforcing steel. And you can just, reinforcing, stem wall reinforcing. So they don't use the term rebar, they use reinforcing bar. Okay? And so just by typing some stuff in, you can find out how important something might be. So that's a way of looking at this. Okay, so that's kind of cool. But then there's more reading I'd like you to do. There's this ARCAT, Architectural Catalog. Okay, and there's lots of stuff. This is a great site. I believe you join for free if you're interested. And they've got CAD drawings, they've got BIM objects, they've got CSI 3-part formatted specifications, and that's what we're going to be talking about. And then they have this really cool spec writer. And so these are kind of cool, and you should just kind of know. And here's what I really want you to look at. This browse by CSI, Construction Standards Institute, Building Product Material Divisions. And these are part of the master format specification, and Revit uses them too. So if you want a spec about concrete, you would go to the concrete specs, click. These are all the different types of things about concrete that are often specified. You go, oh my gosh, where do you keep all these things? Well, when I was breaking in, they were kept in a room full of giant binders that everybody put their specs in, and disreputable companies would put their specs in and take other people's out. But they're organized so that you can find them. If you want a spec about how to clean your cast in place you can do it. And here's some products that help you figure those out, right? If you want to use, like, here's the specs for what you could do: paint and graffiti, remove. So if you wanted to actually say, okay, and you got to do it, and you got to do it this way, and with this stuff, you could just call out that spec. So this is a great site, and there's way more to it than that. And then here's the actual 3-part spec page all by itself. Outline specs, spec wizards. You know, this is kind of cool stuff for you if you're in construction management, concrete, masonry. So we've been talking most about concrete so far, and not too much about any of these other things. Here's earthwork. That would probably be something that we've been working with so far. Earthwork, stabilizers, site clearing, earthwork, dewatering, erosion and sediment controls. So these are all specs that you could call out, and they go kind of hand in hand with that Caltrans best management practices. Okay, and you don't have to really do anything but know they exist. I want you to just kind of like soak it in a little bit. We do have also a resource calendar. Some of this you can't see, but we've got this cool detail that I was showing you, if it ever comes up. Come on, come on. That's a little blurry, but you know, it's the best we could do. There's some calculations to do. There's some, you can't see these completed one, but here's your Revit file to work with this week. And here's your rebar detail. And what you're going to be doing is you're going to be putting these into your Revit file. Now, normally, you can't just cut and paste this in. This is copyrighted material. Unless you have the license to use it, like you've paid an RCAT subscription to get downloads, you really are not supposed to use these for professional purposes. We as educators using a small part of it for a small part of our work that's not making money and not being published, we have a educational right to use these images that are posted on the web. So I'm giving you the authorization to use this in this very, very limited fashion. But normally, a CAD drafter, if they had this, is they'd come in here and you are allowed to make your own drawing that looks pretty much like it. And you could trace it and type things in as you wanted to go, and then erase the image. And now you've got your own for your company. And that's a lot of what entry-level drafting does. They take standards or drawings from your clients that are not quite up to your standards or not quite right, or that you don't have license to use as is, and you create your own version of it. And that is allowed. Okay, so that's what we've got in there. We have two discussions that aren't too bad. There's these cryptic, like, what does this thing mean if you just look at this drawing? Or actually, the idea is if you just read this is the actual specification. If you just read that without having this picture, I doubt if you'd understand it at all. So we use spec drawings to help us decrypt things. And so what I'd like you to do is come up here and read this and see what you get and what you don't get, and then see how much it's clarified right here. And if you can say, oh yeah, this is what they were talking about up there, just a short video again. Okay. I tell you, this was my job when I first came out of school and I had to write instruction manuals for something that I did not know how it worked. And it was going into a nuclear reactor. And so I learned very quickly that you could write stuff and nobody understands it. You have to have drawings that go with it. And we used to have technical illustrators that worked along drafters, and there was a difference between the two. This would have been a technical illustration because it's not to scale and doesn't have dimensions, and it's just to give an idea. And then drafters would do all the different parts of it. But nowadays, we're all just sort of like designers and drafters and engineers all rolled into one. So there's one of them that we've got. And the other one is again talking about assembly instructions. And so like great assembly drawings are really good. And so I just like to have you find one that you like. Maybe you like IKEA, maybe you like Lego, maybe there's something else you like, and just think about what's good about it. You know, why is this good? And post something about it. Okay, so that's what I'm asking you to do on this one. So it shouldn't be too much. I'm hoping that those are pretty minor for you. When we get to the sims, now some people are able to get into the simulator and some aren't. We're up to this book and quills. A bunch of people were able to do the portfolio one. Apparently, it's not your W number password that you put in. It's your Microsoft password that you got and signed up with when you first became a student. And so I'm trying to figure out how you guys find that if you don't know it already. But that's when they're asking for the password, that is what they're asking for, is your Microsoft 365 password that you use like to do Word and stuff like that when you're online at campus. So not sure why they're different and why we can't coordinate them and keep them up, but that's what's going on. And so if you haven't done these yet, I've been still giving you credit because that's still kind of an issue, but you should be up to doing this book and quill one now. And I want to see the actual output. A couple of people just like took a picture of this, and I'm giving you credit, but I want to know that you tried to get into it and couldn't get into it if you had a problem. So there we go. So that's what we're up to. And so let's take a look now at a few different things. I want to, I think what I want to do, we'll go over what to do on your template. Maybe I'll go over the template. Let's see. Oh, and also a couple of people have been just writing some text or putting links in up here. This is a visual summary. Okay, it's part of an executive summary that in many workplaces you're required to submit for quality management purposes. At 2 of the 3 places I worked during my career, this was required of engineers and drafters and designers to actually give evidence to the boss really quickly. Something got done. So these are visualizations. Don't make the boss look around and click, 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 and hopefully this opens and hopefully that opens. These should just be images, and maybe on Thursday, if I've got a chance, I'll make a little compilation of those. Okay, so again, post and peer footings. Now, a couple of people just had 1 or 2 items on here. The idea is that you're doing some research. You're looking at the materials and finding out what's there. And so I'm usually giving you more than 1 item to look at. So I would expect a fair amount of work on these that you've looked at 3 or 4 or 5 things, even if some of them are videos and my links and then other links and other links. So I expect that you're going into detail. Now on this page, you got footing and post and peer because they're kind of the same thing. And on this one, you've got stem wall. So now I want to go over these calculations because I think that that's everybody was doing a good job, and I'll see if somebody asks me, I'll do a video, but I don't really think it's necessary. Okay, and then you're going to be putting this, and it's not exactly this one. It doesn't have all these little circles on it. You'll put the image up over in here in your Revit, and same thing over here. And then there's your book and quill. Okay, so let's take a look at what we've got here. Here are footing calcs, and the reason I want to go over this is there's something in here that you may not be familiar with, and it's a module. And if you can design using modules, you're usually being very efficient with your materials. So a module length is set by some component that you would normally use. So as an example, if this was brick that was going to go on top of the stem wall, I'd make my module length the same as, say, 10 bricks and the mortar. So then every time I use that over and over and over again, I know it can be made, and I know I don't have to throw away bricks, and I know how to calculate very easily how many bricks and how much mortar. So I'm just saying it's a module length. Modules can come in, depends on what your primary construction material is. If it's framing, wood framing, they're usually 4-foot or 8-foot modules because that's the standard spacing module for the wood framing. And that's because sheetrock comes that way. And insulation comes that way. And siding comes that way. So many, many, many of the products are set to a module of 8 feet. So if your module is framing, it's that. If it's brick, it's something else. If it's concrete masonry unit. But there is some sort of module length that says, I'm going to use this basic construction concept over and over and over again. And it's not like I make this and then make another one. This is just a pretend design length that I'm going to use multiples of. Okay, so here are some typical module lengths that are used. 16, 32, 24, 8. Okay, and then a foundation might have a certain number of those modules laid out. I've got a line going this way of some modules and this way 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 and this way. And somehow these things are all figured out so that I have a normal number of those modules in my footing and stem wall design. So what I'm going to try to be doing down here is figuring out how long is my foundation. That's important because I need to frame it in feet, and then I need to know it in inches. Okay, because most calculations are cubic inches first, then turned into cubic feet, and then sometimes turned into cubic yards. We're not going to do that. And then I need to know how many feet of rebar in each run there will be. Okay. And so this gives me my dimensions right here. These are all the dimensions that go with this. And here these are. Okay. So if I'm going to do this first one, I want to find my total foundation length. So if each one is 16, and I have 12 of them, it's 12 times 16. And I'm going to say it equals what's in this box times what's in this box. That's how many feet it is. What's really cool is the way that these spreadsheets work is I can just copy that one down and it says, oh, you want what's in this box and this box. It's called relative copying. So I can just copy those down. Once I get one right all the way across, I'm good. So now how many inches is that? Well, there's 12 inches in every foot. So it's going to be 12 times however many feet I've got. So you start with an equals 12 times whatever is in that box. Okay, and I'm going to back this up just a little bit so you can see everything. There we go. Actually, what I'll do is I'll hide these rows so that I can still make it a little bit bigger and you'll be able to see everything. There we go. Now you can see everything. So let's see. Now, I know that this is 2,304 inches long, and my footing, which is this part, it's the big flat part at the bottom, has a certain thickness. And I know volume is length times width times thickness. So it's going to equal the length, that box, times FT, the thickness, times FW, the width. Wow, that's a lot of cubic inches. Stem wall volume. Stem wall. So it's the same thing, except with my stem wall numbers. It equals the total length of the stem wall times the width of the stem wall times the height of the stem wall. That's a lot of cubic inches too. Okay, now volume of cubic inches to cubic feet. Okay, well, each cubic foot is 12 inches by 12 inches by 12 inches. So I have to take this divided by, and I put it in parentheses just to make sure, 12 times 12 times 12. That converts cubic inches to cubic feet. 288 cubic feet. Wow. And I can do the same thing here. Just copy it over. So that's cool. You can see that's a lot more going into the footing than the stem wall. And these numbers are just random number generated. They don't really mean that much. If I want to, I can make all of these centered here. A little nicer. So now, number of footing rebar runs. I'm going to just tell you that that's going to equal the footing width divided by 4. So footing width divided by 4. And I can't have 4.5, so I either have to have 4 or 5. So I'm just going to round down. I'll be like Florida, I'll use less, 4. So now what's my length of total rebar needed? Going to equal the length of my foundation times the number of runs. 768 feet of rebar in here. So that's how we do this one. Once you've got that, you really just get to copy it straight down. That's kind of cool, huh? And so we're just looking at how much material gets used. In this case, how much concrete and how much rebar is going to get used in this. Okay, and the trick is this rebar is I'm taking it and dividing by 4. All right. So there's one of the calculations that you'll need to do. And I think there's another one. Oh, no, that was both of them all put together. Shame on me. That was both of them. That was your footing and your stem wall calcs. So that's how you do those. That's kind of cool. I'll go over how to add these views to Revit on Thursday. Okay? But I wanted everybody to see how to do those calculations right off the bat. So now let's go ahead. I'm going to come back up here and we're going to talk just for a few minutes about I don't know why I have this one making a copy for you. Okay, but I really want to talk about this concrete strength thing and rebar. And the video that you watched last week was really the classic one. But I like this image right here. Okay. And so the wall, and I'll tell you, if I walk around my house, my foundation has cracks all over it. It's a 40, almost 50-year-old house, and the ground is just not solid under it anymore. It was built on a fairly reasonable building pad, I think. The area that this is used to be agricultural, and they did some work to make it not quite so silty and sandy. But this does happen. What you see right here happens. This is a foundation. And if you can imagine, this is poured right here. And there's rebar in it. And it goes in a certain place and it's tied together. So this footing that transfers the load to the ground, the load is not particularly high per square feet. But look, compressive strength of most concrete is 3,000 to 6,000 psi. 3,000 flexural bending only 400 to 700, and I'll tell you that 400 seems a little high to me. That's pretty high. I've seen it down as low as 1 to 200 in my own testing that I've done. And then the tensile strength is even less. So, a couple 100 pounds per square inch is not a lot. And what happens? I'm going to zoom in on this. Maybe I'll make a Jamboard out of it. I think a Jamboard would be better. So this purple thing, that's a footing, and it started out flat. Started out like that. And then there's some sort of loads that are on it. And it just literally it bends. Because although there's supposed to be ground under it all over the place, you can get voids where something's dug it out, or it's just subsided, or it shrunk away, or something like that, or some water has eroded away. And so it might be supported out here with some ground. Maybe there's some ground out here, but the ground has shrunk away a little bit. And it's only supported out here. And it will bend. It will bend just like that. Well, when it bends, the length along here, the top, called the top chord, the length along there is smaller than along here. And not only that, this is smaller than its original length. And when you squeeze something together to make it smaller, it goes into what's called compression. And we know that that's where concrete is strong. It's strong in compression. So this isn't a problem up here. You can have it bend all you want on the top, but in the bottom, all of a sudden, this is longer. And if I were to draw a little line right here, this little piece is trying to get pulled to the left, and this little piece is getting pulled to the right. That's what these two arrows are doing. And that's called tension. when you pull something apart. That's called tension. So up here, I can hold 6,000 psi. Well, that's just tons. I can really hold it. But what about down at the bottom? I can only handle 400 psi pulling it apart. And that is not a lot. That is not a lot. Does not take much downward force to create that 400 psi in bending. And there's a bunch of formulas and calculations and things like that. But I've taken specimens and pushed down with as little as 40 or 50 pounds. It's like a kid standing on it. Crack. So this is not a lot, depending on how far apart these edges of the erosion have happened. That really is a problem. So how do we handle that? Well, once a crack starts, it'll keep going until it hits something. And that something is going to be a piece of rebar. So if we have a piece of rebar along the bottom, and it bends, it's very, very strong in tension, 30, 40,000 pounds per square inch. So it's not going to crack and break. And so the concrete crack runs into the rebar, and the concrete is actually gripping the rebar. So even if it does crack a little at the bottom, it won't propagate over to the top. So that's what rebar does. And that's standard rebar. If you tension the rebar to begin with, the rebar actually squeezes together and puts it into compression here. But most foundations are just laid in standard rebar, and it's there to prevent the crack that's going to start at this very bottom spot from going all the way to the top and having your foundation break in too. So that's what rebar does. And it's really a cool thing. And rebar is a huge percentage of the use of steel. The biggest, of course, is pipe, and then comes rebar, and then comes the structural channel and things like that. Okay, so that's how rebar works. This purple is concrete, the red is rebar. The concrete gets a load that makes it want to bend. At the top, it's not a problem. It's in compression, very strong. And at the bottom, it's weak. And so it wants to crack. The rebar stops the crack from traveling any further, from propagating. Okay? Now, I would think that when we look at this a little bit and we talk about, you would want to talk about footings, about rebar. So rebar should be in here, right? Footing, forming, pouring, rodding. There's lots of things to put in here that you should be looking up and going over. So here's our concrete strength, excellent in compression, negligible in tensile and bending. And so usually your rebar is placed about 1/4 to 1/3 up from the bottom. Okay, and it increases the bending strength of concrete. Now that's sort of not really true. The concrete itself didn't get better. The foundation system got better. The combination of concrete and steel is better than just concrete alone. But most people say it this way. Okay, it didn't affect the concrete. The concrete still has lousy strength and bending. It just keeps it from cracking because it can grip onto it and not grow anymore. Okay. Okay, now this one, it asks me to scan the document using the keywords concrete footings. Control F brings that up. There's 25 of them in here. And you just go through and you click, click, click. And you read about it. Okay, here's some general stuff. Oh, look at this is telling me minimum width and thickness. The topic here is they help determine sizes. Building codes are there so that we can look at sizes. Okay, and these standards are based on thousands and thousands and thousands, probably millions of instances of construction. Some of it was done in the lab, but most of it is just understanding the material and looking at how things are constructed out in the real world. And different locations have different standards for these. Okay, California has standards, and like these ones, they haven't even talked about earthquake in here, but these are just general. If you have slab on grade and your load-bearing soil is 1,500, then you need this type of footing. Okay? If it's a crawl space, if there's a basement, 2-story, then these are giving you those standard sizes. That's really kind of cool. Okay, but you can just kind of look through here and go, oh, got it, and just look at all 25 of them. Light frame construction, okay, with a snow load or a roof load. And so these are all design resources. Oh, here we are, material and design resources. It's telling you what to do with your material, depending on the design load that you've got. Here's some more. Cast in place, pour in place, cast in place, same thing. Here's some with masonry units. Minimum size. Seismic. It's different. There's something called a cripple wall. I don't even know what that is. I'd have to go look that up. Seismic design. Concrete. Stem walls. Tons of stuff. And this is what I want you to do. And you should say it to yourself. Concrete footings shall be installed in accordance with this and some figure. Unbalanced backfill height is the difference in height between blah. Okay. So if you go through and read this slowly to yourself, you'll just gain so much information. And it's just general background information. But when you talk about did you learn the material, you'll put some of that in there. Okay, so there we go. There's that one. I'm doing well on my time. So this is if you need or want a crawl space below your floor, what would go in there? What would go in a crawl space besides pests? Pipes, electrical. Sometimes people put insulation in there. Data lines. Things like that go underneath. Sometimes you condition this crawl space so that so that you understand the heat transfer from your building into your ground. Sometimes you put a crawl space in there just so your ground is above a certain distance, because you know that your possibility of some sort of flooding of inches to feet. But normally it's so that you can put utilities underneath, particularly gravity flow things like sewage that have to start up near the floor at one end of the building and come out very near the foundation, right under the foundation on the other side. And it has to have a slope. Okay, so let's see. I'm going to now scan it with the word pier. Control F. Pier. 27 of those. And they call them pier and column instead of post and pier. But a column is a pier. Uh-oh. Okay. Tributary load and allowable soil pressure. Well, we've talked about soil pressure, but we haven't talked about a tributary load. We'll do that a little bit when we talk about floors, maybe. Piers, their permanent support shall be protected from. Now, the other thing that you should know is that in some locations, banks will not provide construction loans or even mortgage loans to buildings that are built on piers. They sometimes require a full foundation. And so that's something that you should know about. There are more than building codes. Sometimes there's how people finance a house or a building. Masonry and curtain wall. Curtain wall. Wow, I don't even know what a curtain wall is. Some of these things I don't even know. Spacing, constructed in accordance, bonded into the load-bearing masonry, isolated masonry piers, hollow masonry piers, a pier cap. So you can't just have kind of a weird thing on there. So pier caps, supporting floor girders. That's sort of what my picture was about. Supporting braced walls, seismic design. So this is to let you know that there's a lot of design. You don't have to know these codes. When you begin work for a certain company, usually they'll hand you the code book that applies to them, and you'll spend a week or two and you'll have a copy of it, and you'll look up other drawings, and you'll just get the hang of it. And they'll slowly have you start working along. But you'll be expected to look things up in these codes and to know what some of these terms mean. Okay, so that's what you want to do. And you should, in your presentation, write about some of those terms and some of the things that you learned about, rather than just taking this picture or finding a picture or two of a post and pier. I'm giving specific instructions of what to do. Okay, and our last one that we're going to look at is concrete pour in place. Now, pour in place is what this person is doing up here. They've got forms, and they're going to pour the concrete in place. And then they're going to remove the forming material, and that'll be your concrete. And some can be below ground, and some can be above ground. That's pour in place. And sometimes stem walls are also pour in place. But sometimes there are these cinder blocks, concrete masonry units. And they're usually hollow. And they're sort of like a form. And sometimes they're filled with concrete, sometimes with dirt, sometimes with gravel. Sometimes they're just kind of left hollow. So there's an air gap in there. So people do different things with the hollow part of it, but it's a very strong construction because you can see that this might want to crack at this joint here, but then it's going to run into the thing. And cracks don't generally like to turn 90-degree angles and run. And it also lets you put piping through it very easily. So if you need to get piping from the ground, above ground, or from an interior up or down, this is a really great way to be able to do it. Okay? And then you just make a little knockout and you still have your full structure. So these concrete masonry units are really, really common. And they make good walls too. People make walls out of the concrete masonry unit. But these rebars are there to make sure that these don't shift sideways or back and forth. Okay, they tie this one to this one through that shear that would be on this rebar. So this is a very common way of doing it too. And in this way, when you do it, you do not need to weld your two pieces of rebar together. So that's kind of cool. And we can look, and I'm supposed to look up the keyword stem wall. So here I am back again, and now Control F, stem wall. This is such a great way to this is called scanning, where I want to know about stem walls, and this thing is hundreds of pages long, so I don't want to read all that. Concrete stem wall, and here's a picture of what a concrete stem wall looks like. It's getting it from above, from the concrete foundation up where the floor and the rest of the wall will be. And there's a pretty fancy kind of construction here. And here's some stem wall reinforcing, stem walls with concrete footing. And these are different construction standards that you can use. Stem wall, stem wall, stem wall, stem wall, masonry, stem wall, solid, grouted, bottom of the footing, center line of the wall. Vertical reinforcement goes on the center line of the wall. That's important for people to know because people punch things into these, so they have to kind of know. Supporting above grade concrete walls. That's kind of cool. Look at all this stuff about it. So I'm really just, supporting light frame above grade walls. That's a lot of what we do really often. Okay, so there we go. That's your primary reading, and I'd like you to go through it and do that. I've given you a brief review of it. And then all those things that you looked at should go in here. Okay, all the references that you used, the RCAT, when we start looking at the RCAT, there's going to be more of that too. You should be looking up stem wall, concrete. Those same keywords can get used in there. Okay? There we go. That's our lecture. I'm going to turn off the recording and then see if there are any questions.